Hello everyone, it's June 14th and we have IPO today. I've done it before. Suppose LeetCode will start its IPO soon. In order to sell a good price of its shares to a venture capital, LeetCode would like to work on some projects to increase its capital before the IPO. Since it has limited resources, they can only finish at most K distinct projects before the IPO. Help LeetCode design the best way to maximize its total capital after finishing at most K distinct projects. You're given N projects where the ith project has a pure profits I, and a minimum capital of capital I is needed to start it. Initially, we have W capital. When you finish a project, you'll obtain its pure profit, and the profit will be added to your total capital. Pick a list of most K distinct projects from given projects to maximize your final capital and return the final maximized capital. Okay, so in this case, start is 0, so we can only get 0, so we get 1. And now we find a 1 will give us 3, so we'll be 4. Okay. W is the capital, initial capital. So basically, yeah, it's optimization, right? Profits. I mean, of course, we would like to get the best profits, right? Because we want to maximize. We can only choose at most K, which means we will choose K, right? And in this case, we will, in the first step, we'll definitely try to get the best we can get based on what capital we have. Or shouldn't that be, I mean, if it's greedy, we'll say at each step, we will try to get the best profit based on the capital that we have, which means we need to probably give a sort, right? So let's say we sort based on profits, and if the profits are the same, we will sort based on the capital from low to high. No, I don't think that's the right way. I think it should be sort based on capital, right? Sort based on capital. So we have capital and profits. Okay, so we sort on based on this. So we have 0 and we have 1. Then 1 we have 3, and then 1 we have 2, right? So we're gonna sort. And by doing that, oh, I forgot how the sorting works. I'll have to check it again. So by doing that, every time our current W will go into this, but if we go into this, how do you handle the situation where the project is removed? Basically a binary search, right? A binary search this thing, and binary search. Wow, you look great. Can we have sorted map? I think we need sorted map. Sorted. Yeah, a sorted map. So we'll binary search its key, and then we find the one that's there's only the one smaller, but then you don't know the order of this. Huh. You don't know, right? No, you do not. Because there's never guarantee that the capital that's closest to you will have the highest. Basically, okay, so what we need is, given a W, we want to find the maximum profits with capital smaller than W. We add it to it, and then we just repeat the same process, right? We just repeat the same process. But how do we find, what type of data structure do we need to find the max? We want to find the max profit, right? The maximum profit given, it's like in a range, right? That's what we want, a range. We just want to find a max within this range. Huh. Isn't that segment tree? Alright, because that's all we want. And in fact, I think this might be, we might do doable with a binary index tree. Because given a current W, we want to find from 0 to W what is the maximum, right? And that can be solved using binary index tree. And I don't remember how to implement it, but that is a binary index tree, right? Binary index tree. If we don't do that, we can of course use a segment tree to do this. A segment tree to always find. Now here is the thing. Do we even need to do that? Because we might be able just to do a prefix max for this. Because all we want is the max. No, we cannot. Because we need to remove. Right? If it gets removed, that's the thing. Binary index tree is you add. Right? Every time you add and then we update. You add and we update. It never handles removal. That's an interesting concept. How do you handle removal? But if we don't do... Yeah, how do you handle removal? Or you don't do removal, you say at that position, at that value, you just replace it with something small. Replace it with something small and just update it. Right? You just update with something small. And if you use a prefix sum, a prefix max, it doesn't handle this. But okay, so we might need binary index tree. Alright, so this is binary index tree. Okay. The size of the range, including min max, 1 based BIT. Update the value at position by adding delta. No, we don't add delta. We are not adding, right? We're replacing with some value. and then I is smaller than this. Self.bit I. We don't plus, so it should be the maximum. But we're replacing. That's the thing, right? When you do this, and then if we update with something smaller, and whatever was there already, because you start from the position, and that position needs to get updated. Yeah, I remember it cannot be modified. We can query, but we cannot update it. That's what I remember. I don't think. But that's what we want, right? We want to know the maximum in a range. And then each time we do it, we need to. Lord. We can definitely use segment tree for this. The question is, do you want to implement segment tree? Now the answer is I don't. I never want to implement. If you ask me if I want to implement segment tree, the answer is always no. I don't want to implement segment tree. But I think segment tree will work, right? Segment tree will definitely work because all I need is to find a range, right? You give my current capital. I want to find the maximum within this. I'll use it. I'll set it to 0, and then I'll move on, right? But if we don't do segment tree, and the thing is, it's not really. It can be it's like simpler segment tree because on one side it's deterministic. It's always from the lowest capital, right? Because that's what a capital you have. Right? You can sort your capital, right? You sort your capital from smaller to large, and you have your profits. And all I want to know is, given the range, right? Given the range, what is the maximum in this? Okay. And if I remove something, right? How does the max change? How does the max change? See, that's the part. That's the part that's hard to do. Okay, I think maybe we just segment tree it. Alright, let's see. Okay, no. I'm not doing segment tree because there's a hint. Greedy, sorting, and heap. So we're gonna try heap this thing, not segment tree. Okay. So heap. How do we do heap? How about we sort capital, okay, and we put the, because the capital always goes up, your W always goes up, right? So you have the current W. We can put all the projects whose requirement is smaller or equal to W into the heap. So you throw all of them in, okay, you get those, and you pop the best out. You use it, now you get bigger, and you keep, I got it. That counts as a hint. Yep, that's pretty smart. Much better than whatever segment tree I was thinking about. Yeah. Segment tree is bad, man. Segment tree is bad. Okay, so we're gonna use a heap, right? So priority queue, which say priority queue integer pq equal to new priority queue. Okay, and we need to sort capital and profits. Okay, at the same time. Okay, so it doesn't really matter. We just need to sort capital, but we need the profits to go with it. So we might as well just do, int n equal to len, not len, profits dot length, right? And is n, no, int capital profit, cap prof, new int n 2, right? And then we'll fill in for int I 0I smaller than ni plus plus. Then we do cap prof 0 no, I, right, 0 equal to capital I, and we need to do this. Hold on, we'll be back soon. I do. We should have a fantastic and brilliant also. What's good smell? We haven't put some Tuesday fun. I think I'm growing some muscles. This become a thing every night. So I just realized I picked a really bad time because on Thursday I have to go to office. For the interview. Because Thursday I have to go to office. Because we don't have internet on Thursday. Because they are currently doing an upgrade of it. So there's no guarantee when the upgrade will be over. So chance that on Thursday. It's Monday. We just go to the office on Thursday. But you always do. On Thursday? Okay. Take you wear the mask. Let's go. Let's go. Alright, I'm back. Alright, let's do this. And cap prof I1 equal to profits. Alright, and then Or just do arrays dot sort cap prof. That's fine. I'm not sure if I can do this though. Can we do this? It's Python, so let's do JShell. You can say int, let's say 5 1 4 2 3 3. Okay. Can I do arrays dot sort? No, I cannot. How about we say we do a comparator? Can we do that? Integer dot compare a0 b0. Is this okay? Well, maybe integer. Oh, this is good. 3 3 4. Yo, that's the one. Okay, so yeah, this is good. So we need to do a AB. What is it called? Comparator, right? It's a comparator. Integer dot compare a0 b0. Okay, so now we sort, and after we sort, then what we're gonna do is we'll go through them one by one. Okay, and int result is this, right? So we'll go through them one by one, and each time if it's smaller than a current w, right, we will put it in the priority queue, right? We'll put in a priority queue, and we'll put, and once the current one is bigger, right? Once the current one is bigger, then we check, right? We get it out. How do I do this? Right, if the current profit, if current capital is bigger, then we take one out, put it in, and then go back, and the current is still bigger, and I would take out again. It's still bigger, I take out again. Okay. Until the current is smaller, then we keep moving forward. So I have int I equal to 0. Okay, we have an index. Say while I is smaller than n and k is larger than 0. Okay. If cap of I 0 is the capital, is smaller equal to w, okay, then we add into, we say pq dot add minus cap of I1, okay, I plus plus. Else, if the current capital is larger than w, then we'll pop the biggest, right? Then we say rest or plus equal to minus pq dot poll, right? I'll add that and k minus minus. Okay. Actually no, because prof will equal to minus pq dot poll right? And we'll add that to the capital as well. So we'll say this plus equal to profit and W plus equal to profit as well. So everything goes up, right? Everything goes up. And K minus minus, right? And now we go back up, check again. We do again, we do again, we do again. What if I do not have, yeah, what if I cannot pull? That means I cannot do, then that's the end, right? So in this case, on this, and we have, but if we don't have any, but it's still, yeah, it's fine. So it should be like here, right? If PQ dot is empty, then we just break, because we don't have anything to pull, and we simply just return res. Okay, let's take a look. Does this make sense? No, it does not. Output 1 and 3 should be 4 and 6. Interesting. Okay, that's fine. I think the sort should be fine, and then we'll just say, okay, 0, right? Small equal to W, so we'll add 1, right, to the PQ, I plus plus. 1 is bigger, next one, so we say is empty, no, so everybody plus 1, right? Everybody plus 1, W plus 1, result plus 1, everybody is 1, and K now becomes 1. So we go back up, I is 1, and 1 is small equal to W, because W added the profit, right? So now it's a 1, so we do good, so we'll add 2. Alright, we'll add 2. And the next one, then we add 3. Right? Then we get out. So we should continue going, right? Yep, so it should be K. This should be if I is smaller than N, and otherwise we always go this way. Okay. Now it's correct. I think this is correct. Two. I used a bit of hint by checking what data structure to use for this problem, and the hint says sorting and priority queue, and the solution is very straightforward. You sort capital, right, along with its profits, right? Then we put all the profits in a priority queue if its capital is smaller or equal to W at the moment. Then we choose the largest profit, right, in the queue for the current W. The profit then gets added to W, and we will search capital again to put more profits into the queue if possible. Keep doing this until K projects have been selected, or no profit can be extracted from the queue. Right, so it's O and login and OK, right? Not necessarily. We call it O and login. Okay, let's take a look on how this one goes overall. I don't know. What if we want only one? Does it work? It might work. Give it a shot. Nope. Okay. Wow, it's about the same time that I did. 1, 2, should be 3, expected 5. Huh. Did I make the same mistake as before? 1, 2, right? So we want one project, so the current is 2. Yeah, it should be 3. No. Wait, hold on. K is 1. Huh? How? Wait, hold a second. At most K distinct projects and a maximize a final profit. Your final profit should return W. Shall return W. Yeah. I think we probably made the same mistake. Yeah, I don't know what mistake I made before, but it's pretty good today. Okay, so we don't need a result. Oh shoot, we don't need a result. We don't need this. And this one's also not necessary, so what we can do is do that, and this one W. Okay, that's it. I think nothing to say. We already know how this one's done. All right, I'll see you guys tomorrow. Adios.